Hello everyone, I am Ashwini Saurav Mhetras from Department of Statistics from Rao Bahadur Narayan Rao Borawke College, Sri Rampur. Here I am teaching you statistics for B.Sc second year students. The second paper is continuous probability distributions, which I am going to teach you. Here in that paper there are 4 units. Let's take some introduction part and let's start with this. Before that, you must know what is sample space. The sample space is collection of all objects or units when you do an experiment. When you do experiment, when you want to get some answer for the question, for that purpose you do an experiment, and from that experiment you will get a sample space. This sample space may be finite or infinite type. So when the sample space is countable, that is when it is finite, then you are going to use the discrete probability distributions. This is called discrete random variable, and for that random variable you use discrete probability distributions which you have learned earlier. They are some Bernoulli, binomial, Poisson. These type of distributions are depending on discrete random variable. Okay, which are depend on discrete sample space. That is the sample space which is finite or at least countably infinite. That is the numbers you can count as 0, 1, 2 and so on. But if the question arises that if the sample space is uncountably infinite sample points containing, or there are uncountably infinite number of points in the sample space. For example, I am going to take a weight of person. That weight of person may be between 50 kg to 60 kg. So in the range 50 kg to 60 kg, there are the uncountably infinite number of points, which we can say that they are sample points, and this sample space is uncountably infinite. We write in the way 50 and 60. Here the numbers between 50 and 60 are uncountably infinite. We cannot count it as 1, 2, 3. They are infinite. So this kind of sample space is called continuous sample space. For that sample space, there may be a random variable. Just I have taken this example that x is a random variable is weight of person between 50 kg to 60 kg. These kind of random variables are called as a continuous random variable. And for that continuous random variable, we are learning the continuous probability distributions in this paper. So, in this case, there is a sample space which looks like this: A less than X less than B. And for that sample space, we are going to calculate the probability. The probability will be in the integration form. It will be the area under the curve, because this kind of sample space is not countable. We cannot use summations there as we do in the discrete cases. So here we are going to learn some continuous probability distributions. Before that, we have to learn some concepts as you learned in the FYBS. They are discrete probability distributions. First, you have learned about the PMF, then expectation, mean, variance, mode, MJF, and so many terms you have learned in that paper. The same terms you can learn in this paper, but there will be difference because that x was countable, and here the x we are going to take is not countable. It is uncountable infinite type random variable. So basically, definition of random variable is a real valued function as x of omega, and from that definition we are going to take the definition of continuous random variable. Okay, then further we will go for the probability density function. Here, in case of continuous distributions, instead of using PMF, that is probability mass function, here we are going to take PDF, that is probability density function. Before that, let's take some another examples. One example is X is random variable, which is weight of person between 50 kg to 60 kg, or we can write the it is the electricity consumption of a town between certain range. So in that range all points we cannot count, they are uncountably infinite number of points. Some many examples we can take in this case, or we can take a real line and the numbers between 0 and 1, or the numbers between 0 and 10, or the numbers which are greater than 0 or less than 0, these types of intervals are not countable, and we can take a continuous random variable on that, and further we will go for its probability. So I have say that the probability will be calculated for these type of intervals, and when the interval comes we should take integration part. So let's start with the first concept, PDF, that is probability density function. So what is PDF? As you learned as PMF, that is P of X. Here the PDF is denoted by f of x, and this function f of x is said to be as PDF when it will satisfy the two conditions. What are the two conditions? They are f of x should be greater than 0, that is it should be non-negative for all the range of x from minus infinity to infinity, and the second condition is when you will take the overall integration, that is overall probability, yes you know that it should be 1. So these two conditions are satisfied, then this function f of x is said to be PDF of x. So I am writing these two conditions here. So first condition is f of x should be greater than or equal to 0 for minus infinity to infinity, that is for overall range. And this is the second condition, that is integration from minus infinity to infinity f of x dx, it should be 1. If these two conditions are satisfied, then that random variable and the function is said to be PDF of x. Now we will see some examples on this PDF. We will take some functions, that is f of x, and we will prove that whether, or we will check that whether these functions are PDF or not. How to check? Just we will check these two conditions as we do in the PMF. In the PMF you have checked the two conditions. What are them? They are probability of x should be greater than 0, and second condition was summation of probability of x equal to 1. Similarly, here we are going to check these two conditions. Just note that the summation sign in discrete distributions is replaced by integration sign here, and the PMF P of x was replaced by f of x here. So next part we will see in the next video. Thank you.